Hello and welcome to episode 3 of Let's Talk Concrete, the series where we decode the science, engineering, and innovation behind the concrete that builds our world. I'm delighted to have you with us today as we continue our journey of learning from the finest minds in the industry. Each episode brings new insights, real world challenges, and practical knowledge that help us understand concrete, not just as a material, but as a solution. Today's episode is truly special. We will be diving into the topic, designing reliable mass foundations for modern construction. And to help us navigate this conversation, please join me in welcoming our guest for today's episode, Mr. Suhas Dhuri. It is my privilege to introduce a distinguished leader whose contributions have shaped modern concrete practices in India. Mr. Dhuri, promoter and partner of eCube Concrete Consultants, and also a professional life member of ACI India chapter, ICI, and the Ferrocement Society of India. Under his visionary leadership, eCube Concrete Consultants has grown into a knowledge-driven and innovation-focused organization, known for high-performance mixed designs, plant optimization, structural diagnostics, and capability building programs for engineers and construction professionals. Mr. Dhuri has been instrumental in several landmark projects, from pioneering M75 high-performance concrete for the JJ flyover in Mumbai to developing temperature-controlled M45 concrete for the world's tallest temple in Ahmedabad. His work spans high-rise structures, heritage restoration, sustainable material integration, and nationwide standardization of RMC operations. In addition to his technical excellence, he is a respected mentor and speaker committed to advancing research-backed consulting and elevating the standards of concrete technology across the country. To take a deeper dive into the world of mass foundations, we are fortunate to be guided by someone who has not only mastered this discipline, but has successfully applied it across some of the most challenging and iconic projects. Sir, thank you so much for joining us today on Let's Talk Concrete. To open today's discussion, could you help us understand few simple things? Obviously simple for you, but very difficult for us. I just want to understand, when designing mass foundations, what are the most critical parameters engineers often overlook, but that significantly impact long-term stability and performance?
Thank you for my brief about my career. I have done a lot of work on this concrete. My whole entire career gone in the concrete only. So about your question, see, today what is happening is we are doing these foundations for high-rise building, and if you see the foundations, this is the element of the structure which is never seen again for repairs. So we have to take a lot of care designing the concrete for its durability, for its life. So most of the foundations are having very large volumes to take care of heat of hydration, core temperature and temperature gradient. Since they are buried in the soil also contains a lot of chlorides and sulfates. So need to take the design consideration to take care of those deteriorated. You should not enter into the concrete and deteriorate the reinforcement. Basically the reinforcement deterioration or RCC deterioration due to the corrosion of reinforcement. So how to protect that, those points needs to be considered. Definitely for the stability and the soil conditions, structural engineer is designing the structures. But once it's come to the concrete has to be impermeable, looking into the deleterious materials available around the soil or exposure conditions. So those points need to be understood. But today most of the engineers, they look at only at the strength. My strength is achieved, they are happy. But that should not be a way looking at the high performance concrete or the foundations or mass concrete of high-rise buildings. That is the way they have to look at it. One is their heat of hydration, secondly deterioration due to the environmental conditions.
Sir, you mentioned heat of hydration, which is a very major and big concern for all structural engineers. How to minimize it? Is there any strategy behind it?
Yes, this is you have to go along about the mixed design part. Heat of hydration mainly contributed to the OPC, ordinary Portland cement, 53 grade. But now we have got lot of supplementary cementitious material like fly ash is there, GGBS is there. Then we have process fly ash, we have process GGBS, we have rice husk ash, we have microsilica, we have metakaolin. So lot of materials are available having different reactions with OPC, and you can minimize those heat of hydration. Basically not a heat of hydration, core temperature of that particular element. So you design such a way that you will have minimum core temperature and minimum gradient, temperature gradient. Then it is possible to get a good high performance foundations.
So you also mentioned mixed design adjustments. What kind of design adjustments we need to do if we want to prevent thermal cracking?
First is you have to see the core temperature. There's a lot of empirical formulas are available. Those we can use, and at the initial stage itself you will take that how my concrete will achieve the maximum temperature in the concrete, depend upon the cross section and depth of that foundation. So we can replace GGBS, cement with GGBS or fly ash, and combination of GGBS, fly ash, OPC and microfine material to achieve those parameters. It's possible today. We have got excellent quality of admixtures are available today. We can use those admixtures and lower down your water demand. Basically that is the main concern when you are designing the concrete. And today we are working with, we don't have natural sand, we have crushed stone sand. You know, the lot of variations in that, and lot of other materials also come ingredient with your sand. So take out that, we have very good type of admixtures available. Select properly, or you discuss with your admixture manufacturer and modify your requirement with them. That is the possible today. Another issue is basically a cracking is because of your temperature gradient. To reduce the temperature gradient, we should have very good insulation system. So we can calculate what type of insulation system you require and we can implement it. Today you are aware that most of the people using aluminum formwork, and aluminum is very conductive to the heat, so it dissipates the heat. So when you are using any aluminum foundation, it needs to be put one insulating layer in between concrete and formwork. Otherwise you can go with normal plywood shuttering.
So with increasing demand for durability, how should concrete mix design evolve to address challenges like sulfate attack, chloride ingress, these kind of challenges? How do we overcome these kind of challenges?
See, this will come basically with selection of your ingredient first. Everybody is very comfortable with if I use 100% OPC, I am happy. But that is not the true. You have to use a lot of other materials. Now you take the sulfate attack. So everybody is comfortable to use sulfate resisting cement. But if you go with sulfate resisting cement, you will not get the strengths, whatever you have to achieve. Maybe M60, M50 is very difficult to achieve. And sulfate resisting cement only gives resistance to sulfates. But you look at the Mumbai region, or if you go to Chennai, we are very near to the sea, where your chlorides are there, also there is the sulfates. Now take care of both the things. Better you go with OPC fly ash GGBS combination, OPC fly ash GGBS microfine material combination, and make such a way that you will get list RCPT value, rapid chloride penetration test, list RCMT value, rapid chloride migration test, water permeability and carbonation is possible. So how you are proposing that is your skill. There is basically a technicality is there, also there is a skill also, experience is required. This is not a 1+1 or 1+2 we can do. We have experience how to deal with the materials. Understanding of each ingredient should be there, and then only definitely we can play with those materials and get whatever concrete you want. Whatever concrete you want. We can design concrete as per client's requirement or structural engineer's requirement. That is possible today.
Sir, you were involved in JJ flyover construction, you were involved in Ahmedabad temple construction. These are like massive projects. How did you achieve durability in these kind of projects in terms of foundation?
You see, JJ Flower, if you take the consultant is that time this is a very new project. This initiated in 1998, and that time they specify M75 grade concrete. It was very difficult to achieve because we are working only M30, M40 that time. I don't know whether you know the story of that. The construction has been awarded to Gammon India. Is a well known in the construction field, like now L&T is there or other people like that. So once they come to the concrete, they feel this concrete is not our field. We have to go to the expertise. So they came to us. When I was working with ACC, and hardly 30,000 cubic meter concrete was there. We had to design M75. I remember it took us 6 months to select the aggregates, because aggregate is also very important. At certain level, what happens is aggregate itself are crushing. So to select the quarry, it took lot of time to this. And second is that time, now we have got very good PC admixtures, but that time only SNF admixtures were there. To get the admixtures for that quality, and you are aware the project has been at Bhendi Bazar. You know the Mumbai Bhendi Bazar, what is the traffic conditions there, and then the whole concrete is prepared at Vadala. So from Vadala to we have to carry concrete to the Bhendi Bazar and place concrete after 2 to 3 hours. Retention is required that time. So we also work with admixture people and get desired level of admixture for that project. So there this RCPT was 500. They have kept very large what you are called very strict control over there. We are able to achieve 250, 300. We have used OPC and microsilica within paper type of admixtures, and we are able to achieve those parameters. That is the story of JJ flyover. And we are in the field where when we have tested the cubes, everything, we are reached up to 80 to 90 MPa strength or most of the concrete.
Sir, everybody is talking about Ram Temple in Ayodhya and how the temple was built for 1,000 years.
Yes.
You worked for Ahmedabad temple. What kind of foundation that temple has? Will it work for 1,000 years?
This is actually designed for 500 years. So all the parameters, specification we are designed to this foundation. Is the M60 foundation was there initially, but then structural consultant changed and then they have to M45. This M45 we did with hardly 150 kg of cement, and balance is GGBS and microfine materials. And this is designed to have a water permeability less than 10 mm, RCPT less than 500, RCMT 2 into 5 into 10 raised to minus 12. So those value we are able to achieve with this material. Only good thing is available in Ahmedabad is till today you get very good quality of sand. Sand is playing major role in concrete. So you are able to get those materials, and we are, as you are aware, they are done around 24,000 cubic meter concrete in 55 hours with excellent arrangement of logistics and man management, everything.
Sir, as far as Ahmedabad temple is concerned, what was the depth of the foundation of the temple?
This is 3.4 meter.
3.4 meters. And did you face any challenges in managing the core temperature and differential temperature?
Yeah, definitely. See, there is a specification as per the standard 70 degree and thermal gradient 20 degree. That specification was there. We did lot of trials to optimize the mix proportions. In that, we rarely use OPC, GGBS, microfine material. Two type of microfine material we have used in that, along with lower down the cement content, and able to achieve around 71 degree temperature and around 16 degree of thermal gradient. When you are working for high performance concrete, where you want to have a life more than 100 years or 200 or 300 years, in general concrete, everybody aware that we are using 20 mm aggregate to 150 micron. this working, we are working on various sizes. So there are 3 sizes available generally in for concrete is 20 mm, 10 mm and 5 mm down. That is we call as a sand, or now in Mumbai we call crust stone sand. Now they are having different sizes available in each ingredient, 20 mm, 10 mm and 4.75 below up to 150 micron. So first thing is you are blending in such a way that we should get minimum voids in the mix. Minimum voids, minimum, rather other way technically you can say minimum surface area should be available. So you can use minimum cement paste to achieve that level of strength and good packing density to have a very dense optimized mix. So similarly for cement, GGBS, microfine material and 2 microfine materials. Now the microfine material starts from may 20 micron to below 2 micron level. Cement start from 45 micron to maybe 10-15 micron. GGBS in between that. So you blend such a way that your paste itself will having very dense, and you will surprised to know what sometimes with OPC you use X amount of water, and if you use all the supplementary material, if you use and pack in such a way, you will find that water demand is less. That gives that your packing density is excellent. Once that packing density is there, nothing will go inside. So that is the one of the why with the low cement content you are able to achieve higher level of strength. We have got about 60 MPa strength. So though it is M45, we have got around 60 MPa strength in 28 days. So that is the mixed design skill you can say.
Sir, in India, we have approximately 70 degrees of core temperature. In US, that is approximately 85 degrees. What is the reason of difference and how do you tackle and manage it?
See, this 70 degree temperature has specified in 16700, IS 16700 is meant for tall building. So when this code is introduced, that time you are working for mostly M40, M45 grade of concrete for the raft. Now today for last 3-4 years, scenario has changed. Now you go back to the history why this 70 degree has come. Mostly it has copied from dams. Mostly your gravity dam, concrete dam, you are using concrete, and since you have built up few meters, maybe 50-80 meters height, you generate lot of heat. So there the grade is M20, 20 maximum. With that 70 degree is okay. But the code has picked up something and made M70 degree for normals. That's what I am saying. See, for M40 is easy to maintain, M50 up to M50. But if you go beyond that, it's very difficult. So then what we do, we go for the international code. Now ACI 207 says you can go up to 85. Now if you look back, this mass concrete concept came from the dam where there is no reinforcement. It is only plain concrete. Once you are working with reinforcement, that whatever stress, what will happen once the temperature grows, there is a stress, tensile stress coming in the concrete. It has to be taken care by your reinforcement. That's why even 80-85 degree temperature, there is no crack we are seen, because all the tensile stress taken by the steel. This is one part. Secondly, we have to insulate it. When the thermal gradient take place, because your surface is cooling very fast, then there is a gradients will take place. Suppose I restrain the heat inside the pore, the whole body will hot up. So my gradient will maybe 10 degree, 12 degree, which is acceptable limit. Though your temperature is higher and gradient within the limit of 20 degree, it is very safe. So we can go ahead and accept it. And ACI has done lot of studies and then they have specified this recent 85 degree temperature, this core temperature.
Sir, in large-scale foundation projects, what role do on-site trials, cube testing and real-time monitoring play in validating the mixed design, and how can technology improve this particular process?
Now, as concrete is advancing, your grade is going up. Now, quality control has to be also going to the instrumentation level. Till today, we are only dependent upon cubes. And if you see the cubes is basically representing your concrete, what you have produced in or you are put into the structures. But really, cube doesn't give exact strength whatever is available in the structure. if you see most of the studies, whenever you do core from the structure and the cubes, core strength is always higher than your cubes because of the sections. Now, how this strength parameter has come? Strength is basically a maturity of concrete. Now, maturity is basically a function of time to temperature. What time? That's why our time is 28 days. And the temperature. You can make summation and theoretically you can find out what is the strength of that concrete once you know the ingredients. So now the new techniques are available, the maturity probes are available. Those probes I can put into the concrete and there all the maturity comes on your mobile. So once I do the design, concrete design in laboratory, I can calibrate the maturity probe with the designs and come to the one factor, basically maturity factors. And once you real concrete is going on, your slab or foundations, generally now today people are using for PT slabs, where a pre-stressed slab is there, we stress the slab, stressing after maybe 3 days or 28 days to achieve at certain level of strength. Now today we are dependent on cube strength. Now cube is ideally cured in water tank properly, and we found sometimes the cube strength has achieved, but your cables are sleeping because strength is not achieved at that moment of time, at that particular level. So if you use these probes, probe will give the in situ strength at that point where you are located, what is the strength, and that can be monitored up to 90 days. So on your mobile itself you will get the figures, what level of strength, no question of you testing the cubes. So that is advanced technique is going on and people are working it. We have used this technique in Ahmedabad for few projects and successfully able to estimate the temperature and strength both. So those are techniques available today. Slowly it is picking up, but construction takes a lot of time to absorb the new ideas. Once the structural consultant is accepted, it will go routinely. So slowly all this your cube casting, cube monitoring, cube testing, slowly it will go away and will come with the instrumentation of maturity probe. The maturity probe or maturity concept is not new. There is a STM code is there, STM C1074. That specifies how it works, everything is there. Phenomena is there, everybody knows about this, but it is now since you have excellent program skill is available, so we can interpret and get the results on your computers.
Sir, I have one more question. What theoretical calculation should a concrete technologist do before actual concreting?
See, what happens is there is a various constants available today based on the research paper. So whatever cement system you are using, what I am saying cement system, that is your OPC, supplementary cementitious materials and water. So it has got certain factors. So if you use those factors, suppose I am using X, Y, Z materials, each component has got some factor. Like cement you take, factor is 1. Now if you take GGBS, factor is 0.75. If you use fly ash, factor is 0.5 or 0.45. If you use microfine cement, factor is 2.5. So these are all equivalent cement factors. So whatever I use in design, whatever systems I use, I calculate the equivalent cement, and as a thumb rule, every 100 kg of cement rise the temperature about 10 degree. So accordingly I can calculate, suppose I got 500 kg of equivalent cement, so 50 degree temperature will go up plus my placing temperature. So placing temperature is 30 degree and 50. So 80 degree will go the core temperature, roughly around that. You can work on that. Then other factors will come, how insulation we do, what is the shape, size. But very rough, we can calculate what is the core temperature of the concrete based on those factors. Is possible today.
So to achieve your desired core temperature, you have used Concreto Regler Therme from Nuvoco. How was your experience?
Yeah, this was used in our Nirma corporate house construction going in Ahmedabad. This was very good concrete, and they had done they had done very good concrete. There is not a single crack appeared, and temperature around I think 70, I think 69, 70 degree temperature, and less than 15 was the thermal gradient. And they are able to achieve 52 or 56 MPa in 28 days. There is a further scope. If they have considered 56 days, the further can be reduced with the binder content.
So, sir, with this, we have come to my favorite segment, which is the Mythbuster segment. There are several myths, perceptions in the field of construction, and I would like you to bust one of them. So, my myth question is, normal perception is that we need 28 days for concrete foundation to gain strength. Is it true?
For foundation, you can go 56 or 90 days very easily, because total loading doesn't come within that period. RCC designer has to consider 56 or 90 days strength very safely without having any issue. So you should not consider 28 days for foundations. Definitely not.
Sir, what are your thoughts on this initiative from Nuvoco? Let's talk concrete.
Is a really a very good initiative. And today's scenario, what is happening is engineers don't get time to read, or there is no desire to read. But such program will give a lot of information to the real engineers who are working on site. It is an excellent initiative by Nuvoco. I also thank you to them for inviting me.
So thank you so much for your time today, and there is a very small token of appreciation from our side, from Nuvoco's side. So thank you so much.
Thank you.